Okay, so this is the third part of the whole QA already. I believe today we will be able to finish this worksheet, and tomorrow we'll be going through ammonia itself. Okay, the chapter on ammonia. Okay, so let's start now with this. Okay, so question 8. All the other front part, I believe you should have done it as homework already. As I mentioned, just drop me a text, take a picture, and then ask me to check answers after you're done. Okay, I won't be going through here. I'll be going through the subsequent questions now. So let's start. So as I mentioned, every single time when you look at this diagram, always check what are the reactions that's happening. So I got reaction 1 here. I got reaction 2 here. I got reaction 3 here. I got reaction 4 here. Okay, so I got 4 different reactions that's happening. Okay, 4 different reactions that's happening. So let's look at reaction 1 itself. So green solid adding acid. So what you know is that this is an acid reaction. So for acid reaction, okay, it will be either a metal plus acid, or it could be a carbonate plus acid, or it could be a base plus acid. Okay. Now, so how do I know which reaction it is? You realize that there's a gas produced, so therefore it cannot be base plus acid because it gives only salt plus water. Next one, how do I know whether it's a metal or carbonate? I just look at what's the gas evolved. So knowing what's the gas evolved, I will need to look at reaction 2 now. So reaction 2 itself, bubbling gas into lime water. So this is a gas test, and this is actually a test for CO2. So when I bubble the gas in lime water and white precipitate form, I know that this gas Y will be carbon dioxide. So let's write down, as I mentioned, annotation is key over here. Writing things down will help to offload the amount of memory you can store in your brain, so that will help a lot. So Y is carbon dioxide. Now going on to Z, as I mentioned, when you bubble CO2 into lime water, so just a quick recap, when CO2 gas is bubbled into lime water is calcium hydroxide, equals, what you're going to get is calcium carbonate solid, which is your white precipitate, plus water. So this white precipitate here is actually your calcium carbonate. So we're going to write down here, calcium carbonate. Okay, so I know that, tracing back, I know that X is actually not a metal plus acid, it's a carbonate plus acid reaction. Therefore, X must be something carbonate. Okay, now, something carbonate react with nitric acid to give me carbon dioxide gas and my solution A. Now, because solution A is formed from nitric acid, I know that A would be something nitrate. And it is confirmed by reaction 4. How come? Because you look at, if you add aluminum foil plus aqueous sodium hydroxide and then warming it, step 1, step 2, step 3, realize this is an N-ion test for nitrate ions. Okay? N-ion test for nitrate ion. The gas that turned them red, lemon simple blue, you know that this particular gas would be ammonia. So ammonia gas produced when you do a test for nitrate ion, it tells you that A contains nitrate. Okay, A contains nitrate. Next, reaction 3. I got aqueous ammonia over here. If I just add aqueous ammonia itself, you know that this is a cation test. And for cation test, if I got blue precipitate form, remember all your cation tests, you always got something hydroxide as the precipitate. What hydroxide is this? Blue precipitate tells you that it is actually, oh, sorry, what happened? Oops, sorry, I hope it didn't erase the thing. Oh no, I realized it erased the thing. Okay, sorry guys, let me just, anyway, I'll just fill in the things. Just now the things will be recorded inside the video. So as I mentioned, this will be something hydroxide. Okay, so actually because it's blue precipitate, you know that it's copper 2 hydroxide. Okay, so based on all the things I've written, so I'm just going to highlight that A, I know now must be containing copper 2 ion. It also contains nitrate as well, confirmed by both the nitric acid and also the N-ion test over here. B, as I mentioned, is ammonia. Z we mentioned is calcium carbonate because of the reaction with lime water. We know that colorless gas Y is carbon dioxide, CO2. Then the last one would be, what is X? X is something carbonate, right? X is something carbonate. So the question is, where did the copper 2 come from? The copper 2, if you look at A, it must have come from X. So therefore, X is actually my copper 2 carbonate. Okay? So these are all the answers for X, Y, Z, and ABC. Now, so some of you ask, must I do X, Y, Z first, then I do ABC? No. You can actually do ABC first, then you can do X, Y, Z. So now I'm going to reverse the order a little bit when I go to question 9. Sorry. I realize I haven't do substance C yet. Sorry. This one. Let's look at this one over here. I know it's copper 2 hydroxide form. So copper 2 hydroxide is actually Cu bracket OH2. Okay, so I know substance C is Cu bracket OH2. So to do the ionic equation, it's just that I just need to know what's the ion that forms it. Okay, so 2 hydroxide ion plus 1 copper 2 plus ions will give me my substance C. Just in case sometimes they ask for the ionic equation with the state symbols. So this is aqueous because the Cu2 plus was from the blue solution. Aqueous ammonia, this is also aqueous. So obviously aqueous ammonia, aqueous. Then the last one, it forms a blue precipitate. So the copper 2 hydroxide is actually a solid. Okay. Now, let's go on to question 9. So question 9, instead of doing X, Y, Z first, I'll do ABC first. Okay, so I'm not going to circle and say what reactions, how many reactions there are. I think by now you all will know already. So I'm just going to go from the bottom first. So the first one I'm going to look at is maybe let's look at the test for cation first. Aqueous ammonia added, you realize it's cation test. Brown precipitate insoluble in excess. So this guy here is something hydroxide because it's a cation test. Brown tells you clear cut it's iron 3 hydroxide. So where did the iron 3 come from? The iron 3 actually comes from so the hydroxide comes from aqueous ammonia. The iron 3 must have come from A. So therefore A I know must be iron 3 something. What exactly it is, I don't know yet. So I look at this one over here now. Aluminium foil equals sodium hydroxide and then warmed. This is anion test. Test for my nitrate ions. So therefore, if I test for nitrate, how do I know that there is nitrate present? Is when I know that a gas that turned damn red into blue is evolved. So I know this is ammonia gas. So ammonia gas evolved when I do a test for nitrate, tells me that A contains nitrate itself. Okay? So I realize, oh, I got A, B, C already. So yeah, that's correct. So A itself is iron 3 nitrate. B is ammonia gas. Okay, just write ammonia itself will be good enough. Then C is iron 3 hydroxide. Okay, so now iron 3 nitrate. I do my ABC already. Then the question is, where did the nitrate come from? So A, if you look at it, how was A formed? Is when X reacts with nitric acid to give me A plus a colorless gas. Once again, you realize this one, walao, same thing again. Yeah, it is the same thing. So I'm not going to run through the whole thing again. You know Y is carbon dioxide gas. You know Z is calcium carbonate, which is CaCO3. And hence, you know that X contains something carbonate because it's acid plus carbonate reaction. And you know that iron 3 must have come, the yellow solution, which is iron 3 nitrate, which is A, would have been derived from the brown solid. So actually X will be iron 3 carbonate. So if we were to write down all the answers here, you realize Y is carbon dioxide, Z is calcium carbonate, and X itself would be iron 3 carbonate. Okay? Now, based on all that I've written so far, okay, I hope you realize that for you to get familiar with this is really about practice. And hence, there's like 17 pages worth of this worksheet. Very much of the later part is all practice. It's really because it's to get you used to the analysis and practice and application of the whole thing. Okay? Okay, so let's look at part B here. Write an equation for substance C. substance C is iron 3 hydroxide, which is Fe bracket OH3. So this consists of Fe3 plus, this consists of OH minus. So I write the ionic equation here. FeOH3 is formed by Fe3 plus 3 OH minus. Okay, if you want to include state symbol, this will be aqueous, and because it's a precipitate, it will be solid. Okay, so that's for question 9. So you can see here, I'm blazing through now. Now I'm on the next page, page 10. Page 10 and page 11. Okay, sorry, page 10, question 10. I'll be going through it. So let's start. Okay, so let's look at this one here. Let's identify some of these things here if you are able to see it. Lighted splint, this is gas test. You know that this is about gas test for hydrogen. How do you know hydrogen is produced? You realize it reacted and a colorless liquid is formed. If you scroll back all the way to the top where I mentioned about gas test, you will realize that when I spoke about hydrogen, I did mention that when your lighted splint extinguish or pop sound, you actually get your water produced. So hydrogen gas test is actually about hydrogen reacting oxygen in the air to give you water. So this colorless liquid here is actually H2O, which is water, which then tells you that your lighted splint reacted to give you water. Guess why? It must be hydrogen. In your syllabus, you know that the only way to produce hydrogen is actually metal plus acid, and you can see X itself is a gray solid. So I know that X must be a metal. But what metal it is, I don't know yet. Okay, I do not know. Next, let's look at A. A reacts with dilute nitric acid and then silver nitrate. If I look at silver nitrate here, I know it's an anion test. It could either be chloride or iodide. So I'm testing for chloride or iodide. How do I know what is present? It depends. You got to see the color of the precipitate. So if I got white precipitate, I know B would be silver chloride. The silver comes from here. Okay, the silver of the silver chloride comes from here. The chloride in B comes from my white, from my color solution A. So I know A is actually something chloride because I did the anion test and I know that chloride is present. Okay, so the white precipitate here is silver chloride. Next, I add aqueous ammonia here. This is a cation test. So cation test, I got white precipitate soluble in excess. So white precipitate soluble in excess, if you go back and look at your table of cations, so you know that this must be something hydroxide because as I mentioned, your cation test will always be something hydroxide. So what hydroxide is this? This will now be zinc hydroxide. Okay? So as I mentioned, the hydroxide comes from the aqueous ammonia. Then the zinc must have come from my solution A. So therefore, I know A contains zinc chloride. Now, how did I get A? A was actually a reaction of a metal plus dilute hydrochloric acid. So I know the chloride comes from the dilute hydrochloric acid. Therefore, the zinc must have come from the metal. So X itself must be zinc metal. So drawing all the arrows to help you relate to the different things helps a lot. So now I'm just going to fill out all the final answer here. A itself is zinc chloride. Okay, because it's name, I'm just going to write the name itself. B will be silver chloride. C will be zinc hydroxide. X would be zinc metal, so I just write zinc itself. Y would be hydrogen gas. And Z would just be water. Okay? So write ionic equation for substance Z. So zinc hydroxide is Zn bracket OH2. Okay, Zn bracket OH2. So I know it contains hydroxide ions. It contains zinc ions as well. So I know that for this one here, ionic equation will be zinc hydroxide is the product. This is formed by Zn2 plus ions aqueous plus OH minus ions aqueous to give me the solid. Now, if you look at this one here, there's no state symbol required. So actually, I don't need to write the state symbols. So actually, this I don't need to write. It's just that I want to show you if state symbols are required. This will be the state symbols for this particular um, substance. Okay. Okay. Now, question 11 is something quite similar. So I will just get you all to go and do this as homework. I'm just going to skip this. I want to move on to now question 12, where you realize this one looks a bit more complex. Yeah, because there's a little bit more boxes here. So instead of 6 boxes, now you realize the flow diagram has expanded. So how this worksheet has been structured is give you a very simple flow diagram first, where it's only just 3 substances. And then subsequently, you're going to have more and more substances included. Okay? So let's look at question 12 itself. Let me expand this further. Okay, so let's start. First thing, I got white solid. I heat strongly. So this reaction 1, I heat strongly. So what reaction is this? Reaction 1 is actually a thermal. Generally, what you're going to have is a thermal decomposition, where you're looking at the substance itself breaking down. So you're breaking down substance X into different things. Okay? So what do I have? Colorless gas Y, bubble into lime water, Y precipitate form. So by now, you realize, this one, remember, this bubble in lime water means Y must be carbon dioxide gas. X, this white precipitate, must be calcium carbonate. So straight away, 2 of them I can get already. So I know that Y is carbon dioxide. Y is carbon dioxide. X is calcium carbonate. Okay, calcium carbonate. Okay, next one. I got Z, which is a white oxide. So I know it must be something oxide because it says oxide, right? But what metal it is, I do not know. Never mind. I add dilute nitric acid, dilute hydrochloric acid in. It tells me that A must be something chloride. And this something must be related. So the metal cation here, let's call this X on top, X chloride. Down here must X oxide, down here must also be X chloride. So this particular reaction here is actually what you have is a base plus acid reaction. Hence, you got salt plus water. Right? So this is salt. The X chloride is a salt. Next, add dilute nitric acid, then add silver nitrate. This is anion test for chloride or iodide. Now, white precipitate form tells you that silver chloride is formed. So you know that the silver comes from the silver nitrate. The chloride obviously comes from solution A, which is something chloride. So B, I know, is silver chloride. Next one, let's go back to A. A, I know is X chloride. I don't know what's X. I don't know what's a cation. But good thing is there's a cation test here. CT, cation test. I got add sodium hydroxide, white precipitate insoluble in excess. So if I got white precipitate insoluble in excess, it tells me that C must be something hydroxide. And what's the cation that's going to be present here? This is actually your calcium hydroxide. Okay, so I'm going to write down C is calcium hydroxide. A will then be calcium chloride. Then Z will be calcium oxide. So you realize, after I do, I realize, these 2 things are the same thing. So actually, right from the start, you would have actually known that if you figure this out properly, you know that, actually, X is calcium carbonate. So what is this hitting strongly here? So reaction 1, which is thermal decomposition, right? What's actually happening is your calcium carbonate. When you heat it up, this triangle means heating. What you're going to get is calcium oxide plus carbon dioxide gas. So you can see how the carbonate actually breaks down. So this is about the chemistry behind heating of your carbonates. The carbonates actually break down into carbon dioxide gas and the oxides itself. Okay? Now, so write a balanced chemical equation. So this is not ionic equation, this is balanced chemical equation for the reaction of gas Y and lime water. So gas Y, we know is carbon dioxide gas. Lime water is calcium hydroxide. I know that calcium carbonate will be formed. So actually, we look at it here. Do you realize that CaOH2, if I were to just put CO2 there, what I'm going to be left with is actually water. So you can actually just write down the equation and use a bit of logical thinking. You'll realize that, sure, actually, if I got calcium carbonate, what's left I have? What's the thing that I have left? It's actually water. So in case you forgot this equation itself, you can actually figure it out, okay, by writing down the products and reactant, and you will get the final answer. Okay, so at this particular point, okay, I'm going to pause for about 30 seconds, okay, for you to just take note, digest all the things that I've been saying, okay, digest the things that I've been saying. Okay, so take a short 20 seconds break. Okay, let's go on to the next one. Question 13. So question 13, you can see here it's hit strongly again. Please don't get deceived by all these colors. Okay, you won't know what exactly they are until you did the cation anion test. Okay, so first thing I want to highlight, why I want to go through question 13 is because most people see green, you straight think of iron 2. Cannot. You must do the cation anion test and trace it backwards properly. So what you only know is that this heat strongly is a thermal decomposition. You realize based on X and Y over here, tada, same thing. Not boring, man. It's the same thing. Same thing lah, doesn't matter. You know then good lah. So X is your carbon dioxide. Y is your calcium carbonate. If carbon dioxide gas is produced, so I know W must be something carbonate. Okay. I got black oxide form. So this guy here must be something oxide. I add dilute nitric acid. This guy here must be something sulfate because of the base plus acid reaction. So this is X. Let's not use X. Let's call this Q oxide, Q sulfate. Okay. Next thing, let's look at some other reactions. I add dilute nitric acid and then barium chloride. So barium chloride is a test, anion test for sulfate. How do you know it's present? When you saw the white precipitate here. This white precipitate that's formed is actually barium sulfate. So you can see the sulfate is from here. The barium is from the barium chloride itself. Okay, so I know B is barium sulfate. I look at this other part here, add aqueous sodium hydroxide, cation test. So I know this was something hydroxide. Precipitate form, so I know it's copper 2 hydroxide. So copper 2 hydroxide for C. So what you realize is that when you look at cation test, the hydroxide is obviously from the sodium hydroxide here. The copper 2 must have come from A. So I know A itself would be, instead of writing Q now, I'm going to write copper 2 sulfate. So A is copper 2 sulfate. And where did the copper 2 come from? It must have come from here. So this must be copper 2 oxide. Okay. And where did the copper 2 oxide, the copper 2 come from? From Z, it must have come from W. So W must be copper 2 carbonate. So trace back where the things come from. So W I know now is copper 2 carbonate. Okay. So I have all this. Oh, one more copper 2 oxide over here to write finish every single thing. Okay, so to do this, as I mentioned, draw the arrows, try to relate the things. If you're stuck, it actually helps a lot by writing the things down and then you draw the arrows to see where the cations and anions come from. It will, or to understand the reaction a bit more, it will help you to actually decipher what exactly is the reaction that's happening. Oh, excuse me. Once again, this one here, I'm not going to write the thing. You can just copy from the top. Huh? So this is just additional practice for you. Okay, this one here, I think you can do as homework. This one here, I want to go through. Okay, this one I want to go through. So just go through. Okay, in case some of you thinking about this one I explain a little bit. So 14, you can do on your own. I want to do 15 with you. Okay, so 15, so easy, same thing again. Yeah lah. Okay, then let's write down first. So I know that because of this reaction, X is carbon dioxide, Y is calcium carbonate because of the lime water with the carbon dioxide. And hence, I know that W must be something carbonate. Okay, not difficult. Now, this is the part where it gets interesting because most of you will see here, Z, white oxide that turns yellow upon heating. So is there a reaction happening here or is just what? So this is one of the interesting thing about this. Z is actually something oxide. This oxide will change color when it's heated up. And when it cools down, it will turn back to white. Okay, so it's white when cool, yellow when heated. So this is very unique to this particular elements oxide. Okay, later on we'll decipher what these are. So we're just going to pause it over here. So I know Z is something oxide. I add sulfuric acid. So obviously A must be something sulfate. So let's call this Q oxide, Q sulfate. Yeah, just same thing again, barium chloride. B must be what? Barium sulfate. So when you see barium added, you know there's a test, anion test for sulfate. The result come out obviously must contain sulfate lah, when you see the white precipitate. So barium comes from the barium chloride, the sulfate will come from solution A. So B is barium sulfate. Then what's the cation present in A? I add aqueous ammonia, so it must be something hydroxide. What hydroxide it is? Aqueous ammonia, white precipitate, soluble in excess. There's only one possible one here, which is zinc. So C is zinc hydroxide. And once I know it's zinc hydroxide, where did the hydroxide come from? The aqueous ammonia. The zinc must have come from the solution A, which tells me A must be zinc sulfate. Okay, A is zinc sulfate. And where did the zinc come from? The zinc must have come from Z. Okay, so the zinc in A must have come from the zinc in Z, which tells me Z is zinc oxide. So Z is zinc oxide. So zinc oxide is quite special itself. Just remember that zinc oxide is actually white when cool, and when heated up, it can actually turn yellow. And now, where did the zinc in the zinc oxide come from? Where did the zinc in Z come from? It must have come from W, which means the W must be zinc carbonate. Okay, so you realize once you get a hang of all the key points already, you will trace it back and you will be able to get all the final answer. Okay, why I want to go through this is really because this particular idea about white when cool and yellow when heated is very unique to the zinc oxide itself. Okay? Can? Okay, so now, there are a lot more questions over here. I want to let you all do this one as homework first. So homework that you all can go and do on your own. Homework on your own. Okay, I want to go through question 3. You realize, this one looks a bit funny. This one doesn't look like the usual flow diagram. The pattern looks a bit different. Okay, so that's why I want to go through question 3 here. Okay, so let's start from the top. So they say the flow diagram shows the reactions and properties of substance A, B, C, D, E. Okay, good. First things first, colorless solution of salt A. So salt A, I know is something lah. Salt so must have contain cation, must contain anion. Okay, first test, add nitric acid and then silver nitrate. So this one test for chloride. So yeah, this one test for chloride or iodide. What was the result? I got yellow precipitate, salt D. So what is this yellow precipitate? This will be actually silver iodide. Where did the silver come from? The silver comes from silver nitrate. The iodide comes from solution A. So I know A is something iodide. Okay? Now, next thing, A, you realize, oh, add a few drops of aqueous ammonia. This is cation test. White precipitate form. Yay, but isn't this supposed to tell me whether dissolve or don't dissolve excess? So you realize they split up the reaction here. Can you see they split up? This two is actually cation test part 1. This cation test part 2, where you add a few drops and then after that add excess. So you realize if you combine this, it's actually white PPT formed and dissolves in excess. So if I add aqueous ammonia, it forms a white precipitate that dissolves in excess. It tells me that B here must be something hydroxide, right? Because cation test must be something hydroxide. White precipitate dissolved in excess, it will be zinc hydroxide. And where did the zinc from the zinc hydroxide come from? It comes from here. So I know A is actually zinc iodide. I know D is silver iodide. I know B is zinc hydroxide. Okay? Now, zinc hydroxide add dilute hydrochloric acid. If you know these two react together, I immediately will know my salt C already. Salt C will now be what? Zinc chloride. All right, zinc chloride. Because zinc hydroxide plus hydrochloric acid, your salt form will be zinc chloride. So the zinc from the alkali, the chloride from the acid to give you your salt C. Now, once again, you realize this one anion test for chloride or iodide. Okay, chloride iodide, white precipitate formed. This white precipitate will be silver chloride. Okay, so you realize this one, I did anion test twice, the same anion test, which is silver nitrate. Both give me different results. So if you just look at one glance, you're thinking like, how come isn't the anion supposed to be the same? No, if you think in terms of the whole reaction flow, obviously the anions will be different. But if you're just trying to guess step by step, not trying to figure out what the flow is happening, it's going to be difficult. You're going to get troubled by why is it iodide at one point and chloride at another point. Okay, so be able to see the flow, understand the flow. Okay, the key idea is to feel it. Okay, feel the thing. Okay, construct an equation. This time round with state symbols. Okay, for salt E. So salt E is silver chloride. So I know I got silver chloride AgCl. This is solid. Okay, because it's a precipitate, right? What are the two ions that forms it? Silver ion, aqueous, because it's from silver nitrate. The other one is chloride ion from the salt C, which is aqueous as well, because it's a solution. So I'm going to get this as my ionic equation. Okay? Can? So this one is another one. This one quite simple. I think this one not simple. Because this one is in a different pattern. So let's look at question 4 itself. I want to help you with this. Okay, so first one. Why I don't want to help you is because there's this reaction that you haven't gone through yet. You only know this reaction later on. So I'm going to share with you one reaction based on this. So first thing, let's look at the thing here. Sodium burns in oxygen, give me white solid B. So this one here, you know that sodium reacts with oxygen. So what you're going to get, what is my white solid B? Sodium plus oxygen. What you're going to get is sodium oxide. Because sodium plus oxygen, that's all you can get, right? Next, sodium plus water. Never learned before. So this one you're going to learn in the chapter of reactivity series. Okay, this one will be chapter, I think, 14 or 13, can't remember. So when I have metal plus water, not metal plus acid, metal plus water, I'll get actually alkali. Plus this gas over here, this gas is actually hydrogen gas. Okay, so I can't give this to you as homework because you won't be able to do because you don't know the reactions yet. Okay, then what's the point of putting this particular question here? So if you're revising for next year where you have learned metals already, then of course this question will come in handy. But there's also another point I want to highlight here. I want to show you this part over here, which is this. So I say, what is happening here? I don't know. Okay, this is where it gets interesting. Because why? Normally what you have is a salt that undergoes ion test where you add sodium hydroxide. Okay, when you look at this, you can see this is a cation test. But when you look at this particular one, I got sodium hydroxide here. I add copper 2 sulfate. Do you realize I actually reverse the order? I reverse the position of the salt and sodium hydroxide. So this part here actually is still a cation test. You can see sodium hydroxide added to copper 2 sulfate. Or you can think of copper 2 sulfate added to sodium hydroxide. Regardless, it doesn't matter which order you're adding. The key idea here is that you're adding the alkali to the salt. You are actually doing a cation test. So what is this particular cation test? Cation test lah. Okay, add sodium hydroxide. So I'm going to see what precipitate is formed. So I got pale blue precipitate Phi. Now, you know whenever you got cation test, you always get hydroxide. Something hydroxide, right? So what hydroxide is? The hydroxide comes from the sodium hydroxide. The cations come from over here. So in this case, it will be the copper 2 in the copper 2 sulfate. So my C will be copper 2 hydroxide. Okay, so I purposely left this example here. So you can see that I can switch the position, okay, of your salt and your cation, salt and alkali, so that it may not look like your usual cation test, but actually it still is. Okay, then write a chemical equation for copper 2 sulfate and sodium hydroxide. So this one here, you know that you're going to get copper 2 sulfate, so CuSO4, plus sodium hydroxide is NaOH. I am going to get copper 2 hydroxide, which is Cu bracket OH2. Now, actually, what's happening here is the ions just swap lah. So then I will get Na2SO4. Okay, there I don't need chemicals, I don't need state symbols. Okay, so that's good. Next, I just need balance. The balance will just put 2 over here. Okay, and this will be a balanced chemical equation. Now, take note, although they never say the word balance here, but you're expected to balance. So every time when I ask you write chemical equation, please make sure you go and balance it. Okay, please make sure you go and balance it. Okay, some of the more interesting ones are as follows. So I'm just going to run through the rest of this worksheet already as quickly as I can now. Okay, so that we don't wish, so that we can, it won't be too boring for you lah. Okay, first one, question 5. Dilute hydrochloric acid, add to metal P, no visible reaction. Acid plus metal, no visible reaction. What does it mean? It means that this guy here is an unreactive metal. In your syllabus, I already mentioned, okay, there are only a few examples only, actually 2. Mainly it's copper or silver metal. Okay, I do not know which one it is. Is there any other P over here? Don't have. So if don't have, then I can just randomly say lah. So my suggestion is you can just put this as copper, or you can just put this as silver. Either one of them, it's fine. Next, hydrochloric acid adds silver nitrate solution, white precipitate form. Silver nitrate solution, what is this testing for? This is an anion test for chloride or iodide. White precipitate form over here, this will be silver chloride. Okay. Acid plus sodium carbonate. So this acid plus carbonate test. So the gas R that comes out will be carbon dioxide. Because acid plus carbonate, give me carbon dioxide gas. What's the salt form? Hydrochloric acid will form chloride salt. Sodium carbonate, if you add, it will just actually be sodium chloride. So the anion comes from the acid, the cation comes from the carbonate. So S itself is sodium chloride. Okay. Last one, Q, acid plus metal. What's the gas that's going to form here? Acid plus metal, you get your hydrogen gas. Okay, that's right, hydrogen. B, write the chemical symbol. Okay, so I'm just going to quickly go through this. Sodium carbonate plus hydrochloric acid. What you're going to get is sodium chloride plus carbon dioxide gas plus water, because it's a carbonate plus acid test. Sorry, this one is 2, my bad. So your final answer will just put 2 here and it will be balanced. Last one, our unique equation for precipitate P. P is a silver chloride, which is actually AgCl. So this one easy, just write AgCl. What forms AgCl? You got your silver ion plus your chloride ion. Okay, so this is the speed they can do this. Okay, once you're familiar with it. So you realize chemical formulas, is quite related to this particular chapter. There's always a back part of it. If let's say this kind of flow diagram comes out, there's a back part where you're expected to write the equations. Okay. Now the flow diagram here, as I mentioned, it doesn't. As I'm going to say now, it's not always going to come out as a flow diagram. Okay, it can come out similar to questions like in your tests and exams. It can come out questions like this. Okay, it can come out questions like this where it's just a prose kind of question, MCQ. Okay, so take note, it's not always flow diagram that must come out for QA. Sometimes the more difficult question can come out as well. Okay, so just take note of that. That one, it can come out in other varieties as well. So just be familiar with the concepts. Okay, let's go on. Question 6. We're at page 16 out of 17 already. We'll be able to plow through this by the end of this lesson. Okay, let's go. Properties and reactions of substance A, B, C, D, E are shown. These are the whole thing here. Realize the diagrams getting a bit more complex, but we just do step by step, knowing that arrows is the reaction. It helps a lot. Okay, so you see here, colorless gas burns in air with a pop sound. This pop sound tells you, sounds familiar, right? Now, this pop sound, only one gas can do with it. What is this gas here? This must be hydrogen. Okay, hydrogen is the one that gives the pop sound. Why must air? Air is actually the oxygen in the air that gives you the reaction, right? So hydrogen is gas A. The colorless solution, the colorless liquid here turns universal indicator green. So this one tells you it's a neutral liquid. So B obviously must be water. Okay, as I mentioned before, hydrogen, when you do the lighted spleen, actually you'll produce water. Okay, so B is water. Now I mix with blue crystal C to get a blue solution. So you know that this is just they call it dissolution, or you can just think of it as dissolving. Okay, you're dissolving the thing in the water. Now, what is in blue solution D? I don't know, but it's a solution because I dissolve in water, right? So I look at this, aqueous ammonia. This is cation test, which means this blue precipitate must be something hydroxide. Blue color tells you that it must be copper 2. So this is copper 2 hydroxide. The hydroxide comes from the aqueous ammonia. The copper 2 must have come from the blue solution. So the blue solution must be copper 2 something. Don't know what it is. But next one, I realized I add acid and then barium chloride. When you see barium chloride added, you know that this is an anion test for my sulfate. And hence E, white precipitate form, must be barium sulfate. The barium comes from the barium chloride over here. The sulfate must have come from D, which then tells you that D must be copper 2 sulfate. So if D is copper 2 sulfate, B is water, tells you that C must be what? Copper 2 sulfate also lah. It's just copper 2 sulfate dissolving in water. So teacher, isn't C and D the same thing? Yeah, actually, yes, you are right. They are the same thing. So sometimes people are confused because like C is a blue crystal, D is a blue solution. Like, yeah, it's okay. So it can be the same thing sometimes. So depending on how the question, why is it a C and D? Because one is a crystal, one is a solution. So they are differentiating by the state that the particular substance is. So if I look at this whole thing here, A will be hydrogen, B will be water, C will be copper 2 sulfate. If you want to be more precise, you can say copper 2 sulfate crystals. D will be copper 2 sulfate solution. And then E will be barium sulfate. Okay? And the final one, for this one, B, write a chemical equation for the between blue solution, BD, and barium chloride solution. So this one is chemical equation, not, this chemical equation, not your ionic equation. So blue solution D, you know, is copper 2 sulfate solution. So I'm going to write down copper 2 sulfate. So this will be CuSO4. Barium chloride, so that will be BaCl2. So whenever you got this white precipitate form, actually is the ion exchanging. So the sulfate actually goes to the barium, the chloride goes to the copper. So I'm going to get copper chloride plus barium sulfate. Okay, so easy. Last one, ionic equation. This blue precipitate, you know, is copper 2 hydroxide. So this one you have written a few times already. Today I write a few times also. So I think by now I don't need to go through too much in details. You all should be able to do this already. Okay. So tap tap tap. Once you get it easily, you can be able to do it quite quickly already. Okay. Okay. Page 17, last one already. Okay, this is the final one. This is the most crazy one. Okay, because you look at the flow of the whole thing, it's kind of complex. So this one is important. The more complex it is, the more important it is to read the particular question. Okay. Now, substance X is a mixture of a gray residue and filtrate B. So there is a solid, there is a solution. Okay, so it's like a suspension. Okay. The reaction scheme below shows some of the experimental substance X, which is a mixture. Yellow precipitate Q is lead 2 iodide. Okay, so Q is lead 2 iodide. So I'm going to write here lead 2 iodide. Okay, so whatever clue they give you, just write down first. Okay, so let's go through this. So substance X, shake with excess water and filter. Shake with excess water and filter. So what you're going to realize is that the gray residue must be A. The filtrate here must be B lah. Okay, so the first step here is just to split your A and your B. Now, A, warm with hydrochloric acid. Okay, actually when you see the word gray, you must think could be metal. If I add acid, and then I realize, colorless gas as part of a lighted spleen. What is this gas here? What plus acid will give you this particular gas? This gas is hydrogen gas, which tells me that A must be a metal. What is this colorless solution R? It must be, let's call this A, because it's with hydrochloric acid, so R must be actually A chloride. I don't know what's the cation A, but I can determine because I'm going to do some tests. So color solution R is A chloride. I add silver nitrate. So this white precipitate, I know now, whenever I add silver nitrate, white precipitate will give me silver chloride. So the silver comes from silver nitrate, the chloride comes from A solution R. So I know white precipitate P is silver chloride because this is an anion test for chloride or iodide. Add aqueous ammonia, this is a cation test. White precipitate, soluble in excess. So by now you know this was cation test, is something hydroxide. White precipitate can only be zinc, aluminium, or calcium. But aqueous ammonia, white precipitate will not form with calcium. So I'm left with, so I'd say, yeah, there'll be zinc, aluminium, or calcium. That's white precipitate. Okay. But aqueous ammonia cannot produce white precipitate with calcium. So I rule out that one. Which one is soluble in excess? It is not aluminium, it's zinc. So this is zinc hydroxide. So where did the hydroxide come from? Aqueous ammonia. The zinc must have come from here, which is solution R, which means that R must be zinc chloride. Hydrochloric acid gives you the chloride. The zinc must have come from the gray residue A. So now I know that R is zinc chloride. So let's fill out a bit. R is zinc chloride. P is silver chloride. S is hydrogen. Okay, so that's what I have so far. Now let's go to B. Now, B itself is interesting on the left-hand side because why? I had lead 2 nitrate, I got lead 2 iodide. Obviously, the lead comes from the lead 2 nitrate. Where did the iodide come from? The iodide must have come from B. So B is actually something iodide. Right? B is something iodide. What is the cation there? You realize, so nice, you helped me, cation test. Yes. So white precipitate P, you know, is something hydroxide. White precipitate insoluble in excess. You read this, you know this must be calcium hydroxide. Okay? Calcium hydroxide. Hydroxide comes from the sodium hydroxide. The calcium must have come from here. So therefore, B is actually calcium iodide. So P I mentioned here is calcium hydroxide. What is residue A and filtrate B? This is zinc. Right properly, A is zinc, B is calcium iodide. Okay, I just want to highlight to you, a lot of people just put zinc, calcium iodide. You need to identify A is what, B is what, because this one, if you just write zinc and calcium iodide, no one's not going to know A is what, B is what. So please be specific. Next one, write the chemical equation between the gray residue, which is zinc, and hydrochloric acid. So I know zinc plus hydrochloric acid, I'm going to get zinc chloride plus hydrogen gas. So balance the equation. Ta-da, you get it ready. Last one, write an equation for the formation of yellow precipitate Q. So it's lead-2 iodide. So lead-2 iodide is PbI2. How to get PbI2? You must have Pb2 plus ions and I minus ions, two of them. Okay? So this is the speed that you can do it. As I mentioned, this session is recorded, so you can go back and relook at the recording. Okay, so if there's any point that you need any other clarification, just make sure that you go and see the video, or you can feel free to text me. All the parts that I left blank on this worksheet, they're actually homework for you to go and complete. So please make sure you go and do. The practice is important. You don't practice this, it'll be difficult. Second thing, the difficulty will get lesser and lesser as you try harder. Okay, the more you try, the easier it gets. And lastly, please don't try to memorize everything one shot here. At the start, just go and refer back to all the cation tests and ion tests that we've done before. Okay, once you are referring, you think you're familiar with it already, then you start to don't refer to them and try to deduce what the answer is. Okay, so this cation test, anion test, and gas test, you are expected to memorize it at the end of the day. But for a start, if you can't memorize it yet, okay, get familiar by referring to it first. Okay? Yep. So that's all for this session. Let me stop the recording.